what we will be doing out in this course is we will be traveling in 3 different parts into this course, or rather 4 different parts to start off with. So, our as we are into the first week, our next goal will be to, let me break the course in 3 different segments. The segment 1 will be, as I am doing it now itself in last 2 classes, agriculture and the historical perspective and the philosophy of application of nanotechnology in agriculture. This is our week 1, what we are currently doing. This is the part what we have been discussing. Now, next from here we will move on to the week 2 will be essentially our basic nanotechnology. In this segment, what we will be dealing is synthesis of nanoparticle, scaling up for industrial application, then we will talk about the characterization, then we talk about the quality control, and then use guidelines. This use guidelines will continue in every application we will be talking about. Then from there we will move on to week 3, week 4 and week 5 and week 6. So, this will be, we will talk about the application of different nanomaterials. Till this date we will have a comprehensive review of different crops where nanomaterial has been used in different ways. So, this will be crops, different crops will be dealing. In week 4 will continue with the different crops out here, and maybe some of it will spill over here. Part of it will be in the annual production, sector, then week 6, so week 6, week 7 and week 8. So, this is basically a 8-week course. We will talk a little bit about nano fertilizers, or maybe we may go a little bit up and back and forth. Fertilizer, water technology, and the use of nanomaterial in water purification, water technology. Then we will talk about a little bit about food preservations, and that will spill over into week 8, where we will talk about storage and other post harvest technologies. So this is what is going to consume our week 3 to week 7, the journey, where we will talk about all the different updates of application of nanoparticles or nanomaterials. Precisely, I should not use the word particle continuously, because it's basically the whole family of nanomaterials. We will talk about their applications in different crops, which will include our grain, pulses, vegetables, flowers, so on and so forth. Then on the week 8, which is the concluding week, we will talk about the future, the regulatory bodies who are directly concerned with it, and innovative strategies. So, since we are into the first week at this time, where we are talking about agriculture, the historical perspective, and the philosophy of application of nanotechnology in agriculture. So, coming back, so this is the kind of the layout what we have talked about. So, we will have 8 weeks. So, the first week we will consume what we are doing now, giving you a feel of the subject in terms of, because two diverse domain, nanotechnology and agriculture. So, one has to really understand what really, how these things are going to merge together in future. From there, we will move on to the basic of nanotechnology, where we will talk about different synthesis techniques, how we synthesize different kind of mostly used ones like carbon particles or zinc, iron, sulfur, different gels prepared for delivering nitrogen, phosphorus, potash, and all these things, how to apply silicon for specific crops, borons or micronutrients, how they are being synthesized, could be scaled up, could need it to be characterized. In the week 3, 4, 5, 6, 7. So, essentially 5 weeks we will be dealing with all the applications of agriculture and nanotechnology or nanomaterials in agricultural sector. And in the concluding week, we will move from the role played by the regulatory bodies, and what are the next generation of innovative technologies which someday in a near future or maybe in a distant future will change the way we look at the development of agriculture. So, as I said earlier, there is no looking back. We have already into this area. So, skepticism or critiquing is not going to really take us forward. one critical point one has to realize that global population is increasing, and we have to find out strategies to feed this billions. Yet we have to ensure that sustainability of the system is restored. That brings us to a very tricky crossroad. What next several generations are going to face is how we balance between technology and sustainability. It was fairly easy during Industrial Revolution because we are all into the technology. We never even bothered that many of these technological innovations will come back, will haunt us with the waste products. Now we are suffering. But this time as a race, if we think wisely, decently, systematically, without allowing skepticism to come into the play, because that negative aspect is not going to help us, because we have to move forward, we have to feed people. If we strategize it right, if we do the groundwork right, because we have several tools, if we do the simulations right, if we do the experiments right, I do not see much reason that why we are again going to falter. But of course, nature has its own ways to play the game. But as wise race, human race, we can think, we can philosophize this subject, which is quantifiable, whether it's nanotechnology or whether it's crop production or animal production or preservations and whatever. These are all quantifiable. This is not something which you cannot give numbers to it. If we know within that domain that it is quantifiable and we can simulate what possibly will happen over a period of time, then nanotechnology could change. It has the potential to change the spectrum of agricultural production. It can take us to a level which is, as of now, I believe, is unimaginable by mankind. It is just beyond comprehension. But having said this, I'll again come back, putting the words very clearly that it has to be done in a very, very sincere manner, because of course research happens all over the world and you really cannot control it. People does several things, but then we have to always kind of look through it and then take a step forward. There may be time we may need to take a step backward, but eventually you have to move on, and this will be a journey. So at the time when I'm offering this course, it's just at its very infancy. Maybe when you guys will be teaching the course, I'll be listening, because there will be way too many developments which will occur in next 2 to 3 decades by the time I'll retire, But that is the way to go. That is where the future lies. And if you have an iota of doubt thinking over it, just remember this picture. This is what we are talking about. So this is what we talked about, precision. If I say a plant needs this much, and we should be able to precisely quantify it. If we say that the total crop needs this much, then we should only apply this much. We should not add more, of course with a margin of errors. This is where we talk about the size, and as they say, size matters. It really matters. So nature is already doing all these kind of things. So we have to now go in hand with nature and realize the strategies nature has followed to Nature is even using these kind of stuff to purify water, to clear up things. Are we in a position to emulate nature? So what we are saying, that we are not against nature, we are trying to emulate, we are trying to mimic nature with a powerful tool of nanotechnology. This is why, and this is what I am trying to highlight, that if we play it wise, if we do it right, we can make a difference. Thank you.